In this module of the CompTIA SecurityX certification course, we will dive into security architecture, focusing specifically on resilient systems design. This is essential for robust security architecture and aligns closely with the exam objectives for the CompTIA SecurityX certification. We'll cover the importance of designing systems that can withstand various security threats while maintaining availability and integrity. These principles are foundational for any security professional aiming to build resilient and reliable solutions. Let's get started on our journey to mastering resilient system design. In this section, we're diving into the fundamentals of resilient systems design, an essential component of any robust security architecture. Resilient systems ensure that your infrastructure can withstand and quickly recover from adverse conditions, an important aspect directly related to the CompTIA SecurityX exam objectives. Key areas to focus on include availability, ensuring that systems are reliably accessible whenever they're needed. This involves planning for redundancy and contingencies to minimize downtime. Integrity, maintaining the accuracy and trustworthiness of data across the system. This is crucial for preventing and detecting potential breaches or corruption. As we move forward, we'll explore these concepts in depth and discuss specific design considerations that enhance system resilience. Understanding and implementing these elements is critical for both securing your systems and successfully passing your certification exam.
On this slide, we'll focus on availability design considerations, which are crucial to ensuring our system remains operational and accessible under varying conditions. Load balancing is a fundamental technique used to achieve this. It distributes network or application traffic across multiple servers, ensuring that no single server becomes a bottleneck. By spreading the traffic, it helps prevent any one server from becoming overwhelmed, which enhances the overall availability of the system. For practical implementation, using load balancing tools is essential. For example, you can employ haproxy with the command haproxy.cfg to load balance requests effectively. Similarly, if you're using nginx, you can reload the configuration with nginx reload to apply the latest balancing rules. Understanding and implementing these design considerations are key to creating resilient systems that maintain high availability even under stress or during peak usage times. On this slide, we focus on recoverability design considerations. Recoverability is crucial for minimizing downtime and data loss in the event of unexpected failures or disasters. Key concepts include implementing robust backup solutions, establishing redundancies, and devising comprehensive disaster recovery plans. From a practical standpoint, it's important to perform regular backups and frequently test your recovery procedures to ensure they work as intended. Tools such as rsync and restic can be invaluable in these efforts. For instance, you can use the sync command to synchronize files between locations. Shell rsync //dest. Similarly, to backup data using restic, you can run shell restic backup path to data. By incorporating these practices and tools, you enhance your system's capacity to recover swiftly and effectively from incidents, thereby maintaining service availability and data integrity.
In this slide, we will discuss interoperability design considerations. Ensuring compatibility between systems and components is crucial for seamless operation within your architecture. It's essential that all parts work together without conflicts, and this is where APIs and middleware come into play. APIs act as interfaces that allow different software applications to communicate with each other efficiently, while middleware serves as a bridge, enabling interaction and data exchange between disparate systems. To illustrate, consider integrating a new security appliance into your existing network. The objective is to do this with minimal disruption. By leveraging robust APIs and middleware, you can ensure that the new appliance communicates effectively with your current systems, maintaining network stability and security without significant downtime or complications. Interoperability is a key factor that should be included in your design considerations to facilitate smooth integration and enhance the overall functionality of your IT infrastructure.
When considering geographical factors, there are several key elements that need to be addressed. These include data sovereignty, latency, and regional compliance. Data sovereignty is crucial as it pertains to the laws and regulations governing data in different regions, ensuring that data is stored and processed within specific geographical boundaries. Latency is about minimizing the delay in data transmission, which can be achieved using content delivery networks, CDNs, to cache content closer to users. Regional compliance involves adhering to local data protection regulations. Strategies to address these geographical considerations include leveraging CDNs and geo-redundant data centers. CDNs help in reducing latency by distributing content across various global locations, while geo-redundant data centers ensure data availability and compliance by replicating data across multiple geographic regions. For instance, hosting data in multiple regions can help meet regional compliance requirements and ensure high availability by preventing data loss during localized failures. This strategic distribution of data ensures that users experience minimal latency and that their data complies with local regulations.
On this slide, we are delving into the differences between vertical and horizontal scaling. Vertical scaling involves enhancing the capacity of an existing machine by adding more powerful components like CPU and RAM. This is akin to upgrading the hardware on a single server to handle an increased load. In contrast, horizontal scaling means adding more machines to your infrastructure to distribute the load. This can be likened to adding more servers that can work together, sharing the burden of incoming traffic. The diagram accompanying this slide visually compares these two approaches, illustrating the structural differences. A common scenario is deciding whether to scale a web service vertically or horizontally. For instance, if your current setup can handle increasing loads simply by upgrading the server, vertical scaling may be sufficient. However, for larger, more distributed applications, horizontal scaling might be the more efficient and reliable choice.
Persistence refers to the ability of data and state to remain constant across sessions. This is commonly used in databases and stateful applications where it is crucial to maintain the continuity of data over time. For instance, user profiles in an application need to be stored persistently so that users find their information intact whenever they log back in. On the other hand, non-persistence means that data and state are temporary and reset after the session ends. This approach is typically found in stateless applications like web servers, where each user request is treated independently without knowledge of previous interactions. An example would be deciding when to use a persistent storage solution versus a non-persistent one. For a banking application, persistent storage is essential to ensure that account balances and transaction histories are retained accurately. However, for a streaming service's session management, non-persistent storage might be sufficient since individual session data does not need to be retained long-term once the user logs out or shuts down the application. The choice between persistence and non-persistence ultimately depends on the specific requirements of the application in question.
On this slide, we have a summary of key points that we've covered in this section. Firstly, load balancing is crucial for achieving high availability in your systems. It ensures that your applications can handle varying levels of demand gracefully. Next, recoverability is all about planning for backups and disaster recovery. By having robust recovery plans, you can minimize downtime and data loss when unexpected issues arise. Interoperability is another critical factor. It means ensuring that different systems and components can work together seamlessly, which is essential for eliminating bottlenecks and improving overall system efficiency. Geographical considerations play a vital role, especially when it comes to compliance and regional efficiency. Different regions may have specific compliance requirements and varying levels of infrastructure development that could impact your application performance. Scaling approaches highlight the importance of choosing the right strategy for scaling your applications. Whether it's vertical or horizontal scaling, it's vital to tailor your approach based on your specific needs. Lastly, persistence needs emphasize matching your storage solution to the requirements of your application. Whether you need persistent storage to retain data across sessions or non-persistent storage for temporary state management, aligning your storage strategy is key to performance and reliability. These key points form the basis for designing robust, efficient, and resilient systems. In this final slide, let's wrap up with some crucial thoughts and recommendations. Best practices. It is essential to regularly review and update your design strategies to ensure they meet current needs and leverage the latest technologies. This helps maintain high availability and ensures your systems are resilient. Additionally, always test and validate any infrastructure changes before rolling them out into production. This minimizes potential disruptions and ensures any updates or tweaks perform as expected. Next steps. For those looking to dive deeper, I recommend further reading on advanced security architectures to strengthen your system's resilience and protection. Engage in practical exercises and implementation projects to solidify your understanding and skills. These activities will prepare you to effectively apply what you've learned and keep your systems secure, scalable, and efficient.
As we conclude, let's take a look at some key references that will help solidify your understanding and aid in further exploration of the topics we've covered. First, we have the CompTIA SecurityX Exam Guide, a comprehensive resource for exam preparation and understanding fundamental security concepts. The NIST SP 800-53 is crucial for diving deep into security controls and compliance requirements. For those interested in enhancing their knowledge in system architecture, several books by industry experts are highly recommended. Additionally, practical tools are indispensable in real-world scenarios. You'll find the official documentation for HAP Proxy and Nginx invaluable for mastering these load balancing solutions. And for data synchronization and backup, the user guides for rsync and restic provide detailed insights into their capabilities. These materials will serve as excellent resources for both novice and experienced professionals aiming to deepen their expertise.
Thank you for your attention. I hope you enjoyed the content. If you did, please leave a like and comment below to share your thoughts. Don't forget to subscribe to the channel for more insightful material. Also, feel free to share these resources with your friends and colleagues who might find them useful. Lastly, connect with us on social media for updates and more interactive discussions. Your engagement helps us improve and continue providing valuable content.